All right, so today is Tuesday the 6th. If you haven't already, please make sure that you put your first and last name at the top of your packet. Okay, it is given on Tuesday, again, 9/6/22. The assignments that are due this week are the warm up, the homework, and we have a quiz on Friday. Our quiz on Friday is going to be on comparing and ordering real numbers. So we should be able to put real numbers in order from least to greatest. And we're also going to categorize numbers. So that means we need to be able to put numbers, tell if a number is rational, irrational, an integer, a whole number, natural number. Okay. So we're also going to be categorizing numbers. Mm. Our essential questions for this week, we need to know the difference between a rational and irrational number. We talked about that last week. We're going to talk about that again today. We also need to be able to list our perfect squares. Perfect squares meaning the with the note cards that we did for Thursday night's homework. You should know those by heart, 1 through 12. So 1 times 1, 1, 2 times 2, 3 times 3, 4 times 4. You need to know all of the perfect squares 1 through 12 by heart. Okay, so you have note cards. You need to be studying your note cards. Sit up, Carter. You should be able to list your perfect cubes 1 through 6. Okay. So 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, all the way to 6. And then you should be able to estimate irrational numbers or those non-perfect groups. So this is our goal for this week. These are the things that we should be able to do. Tuesday, remember, this is not mandatory that we write down what we're going to do in class. I just want to make sure you know what we're going to be doing today. You should have already completed your Tuesday warm up. Okay. I'm going to go over categorizing numbers. So I'm going to do teacher is going to model categorizing numbers again. Okay. And then I'm going to also model, and it's on the board, um, decimal percent conversions, which is going to be our segue into how to order numbers. We're going to do some guided practice problems, and then we have a coloring activity that we're going to do at the end. Okay, so we're again modeling. I'm going to be modeling categorizing numbers. I'm also going to be ordering numbers. We're going to do some practice, and then there's an activity at the end. Okay. Your homework is here. We're doing the Tuesday night homework. We're gonna watch the video. Okay. The video I'm gonna send out it's already on Canvas, but I'm also gonna send it through Remind as well. So those of you that want that easy access, you can watch it from your phone. Okay. Any questions, comments, or concerns? Yes. It's weekly quiz on Friday. All right. All right, we're going to pause real quickly. I'm going to give you this sheet. Those of you that are not going to the restroom are going to get this sheet. I want to see if you can make the conversions while we're taking a bathroom break. For those of you that are staying behind, can go ahead and start doing this sheet. If you're going to the restroom, let's line it up. All right, good folks. Let's look at the warm up. Okay, let's see. What would be the best measurement for the amount of water a cat drinks? Would it be gallons or fluid ounces? What do y'all think? Does a cat drink gallons? What's a gallon look like? Yeah, like the massive jugs. Fluid ounces. I didn't mean to laugh. It's fluid ounces. That poor cat would just, the gallon is bigger than the cat, right? All right, so there would be fluid ounces. All right, let's see if we have enough time. Let's try this one. Angles X and Y are supplementary. What does it mean to be supplementary? Y'all remember that word from last year? It's two angles whose sum add up to what? Not 80, not 160. 360 is a complete circle. 90 is a right angle. That's complementary. Somebody said it's 180. So it's two. I knew somebody said, I just didn't know who. It's two angles whose sum measures 180 degrees. So the two added together, we have angle X plus angle Y. I'm going to put little lowercase m. The measurement of those angles added together is equal to 180 degrees, okay? All right, so the lowercase m in front of the angle symbol means the measure. So the measurement of angle X plus the measurement of angle Y is equal to 180 because they're supplementary. Now it's saying angle X measures this expression here, 5x minus the 6. So I'm going to replace angle X with this expression, 5x minus 6. This is X right here, and I'm going to replace it, substitute this expression in for it, okay? Angle Y measures 141 degrees, so I'm going to replace Y, so bring down the plus, and I'm going to replace it with 141 degrees, okay? So now what I have is a good old equation, okay? I have an equation there. So I need to find the value of X. So that means I need to isolate X, get X by itself. So let's look on the side that has X. This side has X on it. I got to get X by itself. Let's combine terms that are alike. What terms can I combine there that are alike? Let me move this out the way. Does anybody know what terms can I combine? I have 5x minus 6 plus 141. What terms are alike there? What are the like terms? Hayden, sit up, please. Lexus, sit up, please. What terms are alike? What are my like terms here?
What song are you singing now?
We gon' make it. We gon' make it. We gon' make it. I don't know. I always got a song in my head. Come on. It keeps me motivated. Like terms here are going to be -6 and plus 141. All right, type that in and see what you get. You got 141 minus 6, or -6 plus 141. What do you get? 135. Okay, so we have 5x plus 135 is equal to 180. All right, so now what do we do to get x by itself? What are we going to get rid of next? Are we going to get rid of the 5 that's attached to the x by multiplication? Or are we going to get rid of the plus 135? The plus 135. Get rid of all numbers that you can add or subtract to move. What's the opposite of adding 135? So in order to move a positive 135, you have to subtract it. Use your calculator again. Let's subtract 135 on this side. This is 0, and we're left with 5x over here. This is gone. Use your calculator. Somebody said it, I think. 180 minus 135. Type that in. What does that give you? 180 minus 135. Say again. 45. Okay. Now what do we do to get x by itself? How do we get rid of the 5 that is attached to x by multiplication? Dividing. Very good, Ricardo. We're going to divide both sides by 5. What's 5 divided by 5? 10. Not 10. Somebody said it. Good. 1. So this gives me 1x or just x. Bring down the equal. What's 45 divided by 5? 9. Very good. Okay, I'm going to pause for the calls, give you a chance to write this down. And that is a 9 there. Okay. Our homework, we are going to do Monday. You see where it's labeled Monday? Let's put Tuesday here. This is what we're doing tonight. Now we're going to put this in our folder. What side of the folder are we going to put this on? Work to do. Okay. We're going to put this on the work to do side. What should be in the completed or finished work? The last week's packet. Are we throwing any packets away? No, please don't do that. See, I put mine in the correct place. The work to do, week 2 packet. The finished work was the packet from last week. Okay? Take out your interactive notebook, please. Take out your interactive notebook. The last page we did was page 8. Real number system definitions. Okay. We're going to go to page 9, and we're reviewing the real number system. Okay, so Q1 in the corner. This is page 9. Review real number system. Okay. All right, let's draw a huge box. What is any and every number? Any and every number you can think of is going to be what kind of number? What's any and every number you can think of? It's a real number. Any and every number you can think of is a real number. That's any and every number. A real number can be a whole number, such as 5. It can be 0. It can be a negative number, such as -3. It can be a fraction, such as 1/2. It can be a decimal, such as 0.6. It could be a repeated decimal, such as 5.2 repeating. It can be pi. It can be a perfect square, the square root of 25. It could be a non-perfect square, the square root of 42. Okay? And what about the decimals, the non-terminating decimals that have the dot, dot, dot at the end? It can even be that too. So let's include that. Let's include 7.238 dot, dot, dot. It repeats, but it does not have a pattern as to how it repeats. It's still a real number. It is still a real number. I'm going to pause for the calls. Okay, so what 2 groups are real numbers broken into? What and what? What 2 groups is a real number broken into? Either it's this or it's that. Not integers. Good guess, though, baby. That is a category. It's not integers. Keep going. Rational or irrational. Either a number is rational, that means it can be written as a fraction, or it's irrational, it cannot be written as a fraction. Okay? Either it's rational or irrational. These numbers either going to fall under rational or irrational. Okay, now I want you to look at these numbers. I want you to put either the number 5 is going to go under rational or it's going to go under irrational. 0, either it's going to be rational or irrational. I need you to do all the numbers. Either put the number under rational or put it under irrational. I'm going to pause for the calls. These numbers right here, either they're going to be rational or irrational. You decide. A number can be written as a fraction is rational. A number that cannot be written as a fraction is irrational. There are only 3 types of irrational numbers. Okay? Pi, non-perfect roots, and non-terminating decimals. I'm going to pause for the calls to give you a chance to put either the number rational or put it under irrational. Do all those numbers, please. Excuse me. 5. Did you put 5 the real number? Is it rational? Can you write 5 as a fraction or is it irrational? You can't write it as a fraction. You tell me which one. It is rational. Okay. You can write the whole number 5 as a fraction. Okay. So we did that one. 0. Is 0 rational or irrational? 0 is rational. Okay. -3. Is -3 rational or irrational? -3 is rational. You can write -3 as a fraction. It is also an integer. 1/2. Is 1/2 rational or irrational? It is rational. Try somebody different. Okay, Carter. Is 0.6 or 6/10 rational or irrational? It is rational. Very good. I'm going to try somebody different. Jaden. Is 5.2 repeating? Is it rational or irrational? It's rational because I know what number is coming next. Okay, good try, baby. When you know what number is coming next, you can write it as a fraction. All right, I'm going to try somebody different. Aaliyah, is pi rational or irrational? It is irrational. Remember, it is a non-terminating decimal. It goes on forever. You don't know what number is coming next, so it's irrational. I'm going to try somebody different. Okay, Arturo. The square root of 25, is that rational or irrational? It's rational. The square root of 25 is a whole number. What? What is the square root of 25 equal to? Does anybody know? What number can be multiplied times itself to give you 25? Carter? 5. Since the answer is a whole number, then the square root of 25 is rational. The square root of 42, Haley? Rational or irrational? Sorry. It's irrational because the square root of 42, very good try, baby. The square root of 42 is a decimal. Miss Reyes, how do I know that? I can type that in. Look. Square root button. It's right here. Do you see this yellow button? So you press yellow and x squared, that's square root 42. Do you see how it's a decimal? Since the answer is a decimal and not a whole number or an integer, then this is going to be irrational. The square root of 42 is irrational. Okay. What about 7.238 dot 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 dot? Is that rational or irrational? It's irrational because you don't know what number is coming next. Good job, y'all. Okay. All right, so now let's look at the rational. Rational numbers can be broken into 2 different groups. What 2 groups do you think rational numbers can be broken into? What do you think?
Integers.
Integers, very good. It's either an integer or it's not an integer, okay? Very good, Abby. Non-integers are fractions and decimals. Integers are whole numbers and their opposite. Positive numbers negative numbers, and 0. They do not have fractions attached to them. They do not have decimals attached to them. So take each of these numbers and put them either in a non-integer or an integer. Do 5. Where does 5 go? Then 0. Where does 0 go? Negative 3. Where does it go? 1/2. Where does it go? This is 0.6. Where does 0.6 go? Where does 5.2 repeating go? And where does the square root of 25 go? I'm going to pause for the cause. It's either going to go under a non-integer or it's going to be an integer. Either it's not an integer or it's an integer. All right, so let's see what we have. We have 5. All right, is 5 an integer or not an integer? Is 5 an integer or not an integer? Somebody said not an integer. Do we agree or disagree?
Agree.
Okay, it is an integer. 5 is an integer. Okay, the only thing that's not an integer are your fractions and your decimals. Okay, all right, so we got 5. Let's go to 0. Is 0 an integer or not an integer? It is an integer. 0 is an integer. Okay, remember, integers are positive numbers, negative numbers, and 0. Integers do not have fractions attached to them. Integers do not have decimals attached to them. Okay. All right, so let's look at negative 3. Is negative 3 an integer or is it not an integer? It is an integer. Negative 3 is an integer. It does not have a fraction attached to it. It does not have a decimal attached to it. 1/2. Is 1/2 an integer or not an integer? It is not an integer. Fractions are not integers. Decimals are not integers. 0.6. Is 0.6 an integer or not an integer? It's not an integer. 0.6 is not an integer, or 6/10. THS on the end, okay? Is 5.2 repeating or 5.2 tenths repeating? Is it an integer or not an integer? It is not an integer. It is a non-integer. And the square root of 25, what's the square root of 25 equal to? 5. Is that 5 an integer or not an integer? It is an integer. So the square root of 25, because the answer is 5, it is an integer. And I can put equals to 5. It is an integer. Did anybody get most of these right? Okay. All right, let's break down integer. What two groups do integers fall into? It's two groups. What two groups are those? Negative numbers. Very good. And whole numbers. Excellent job. Either it's a negative number or it's a whole number in this group right here. So now you're going to decide if 5 is a negative number or is it a whole number? Is 0 a negative number or is it a whole number? Is negative 3 a negative number or a whole number? Okay, I want you to put these numbers either in this box or this box. Okay, let's do that now. Pause for the cause. All right, let's look at it. First number is 5. Is positive 5 a negative number or a whole number? 5 is a whole number. Okay. Is 0 a negative number or a whole number? 0 is a whole number. Very good. Is negative 3 a negative number or a whole number? Negative 3 is a negative number. The square root of 25, which is 5, is that a negative number or a whole number? Whole number. Oops, sorry, y'all, 25. All right, so now what two groups will whole numbers fall into? And this actual number is in a category by itself. What number is in a category by itself? 0. 0 is one of those special numbers. What's so special about 0? Anybody know the definition of 0? Some characteristics of 0? 0 has no value, somebody said. What else? It's in the middle of your number line. That makes it neutral, right? And what was you gonna say, babe? It doesn't have a value at all, and it's a placeholder, okay? And we could think of some other characteristics, but those are the basic ones. All right, so we got 0 in a category by itself. It's one of those special numbers. Either the whole number is 0 or it's a what? What's a counting number? What's that called? Not neutral. 0 is neutral. We said 0 is neutral. So neutral is the wrong word for that group. But it starts with an N, though. It does start with an N. Carter, you want to take a guess? Natural. Very good. All of these are great guesses, okay? So we got natural numbers. Natural numbers are your counting numbers. So I want you to take these numbers and put them into the correct box, okay? Pause for the calls, Miss Reyes. Let's look at this one. 0. Is 5 0 or a natural number? It's natural. What about 0? 0. What about the square root of 25? It's natural. The square root of 25 is equal to 5, which is a natural number. It's a counting number. All right. Any questions? No questions. Are we sure? All right. Let's go to our next page, please. All right. We're going to do decimal. Actually, before we do that, I have a sheet that I'm going to give you. Stand up, stand up. Jane, do you need to stand up, baby? Count to see how many there is. Count to see how many that is. Count to see how many that is. Count to see how many that is.
You want it to color.
And count to see how many that is. All right, need one more.
You didn't count, man.
All right, any extras or do we need one for your table? Everybody got one? Thanks, babe. Thank you, sweetheart. All right, so we are going, I'm getting ready to give you a box of coloring. And so you are going to color, listen, the shape orange if it's real and irrational, and that's all it is. If it's real and rational only, real and rational, you're going to color it yellow. If it's real, rational, and an integer, color it purple. If that one number is real, rational, an integer, and a whole number, color it blue. And if it's real, rational, an integer, a whole number, and a natural number, you're going to color it green. Okay? All right. So I'm going to pause for the calls and give you some colorings. All right. What's negative 24 divided by 2? What's negative 24 divided by 2? You have your calculator. Type that in. What's negative 24? When I do negative 24 divided by 2. Negative 12. Is that a whole number?
Yeah.
Negative. No, it's not a whole number. Is it real? I should have said real first. It is real. Is it rational or irrational?
No, rational.
It's rational. Is it an integer? Is negative 12 an integer?
Yes.
Yes, it is. So we're going to color it purple because it's not a whole number, but it is these. So this is color. The color of this one is purple. This is purple. All right, so put your markers back. I want you to leave your markers on the desk for the next class. Colored pencils, markers, whatever. They're writing tools.
You want to see the calculators?
No, the calculation you put back.
I'm gonna do this.
All right, let's put our calculators back and grab our phones, please. What side of the folder does this go on? Work to do. Work to do. Please put both of those sheets on the work to do. Put it on the work to do.
I know, they can put this on some. I like to have something.
As soon as I have all the calculators, I can dismiss us, okay? All right, cell phone number 1, cell phone number 3, cell phone 14, cell phone 26, and cell phone 27. I'm missing calculator 18. I'm missing calculator 14. I'm sorry, 15. I'm missing calculator. Can somebody turn 20 and 21 around? 25, I don't know if those are in the right place. 29. Y'all, please turn so I can see the numbers. They're checked out to your name, so I want to make sure that yours is actually present. Come on. There, we got it. Thank you for turning those around, baby. Thank you, baby. All right, section 1, let's go. Is that yours, code number 4? Is that yours? Can you pick it up, please? Section 2. Don't leave. What's that right here? What is that?
That's Janie.
Ow! Why you didn't tell me that your stuff was there? All right, everybody else, you gotta speak up, honey. I don't know. Don't work with that stuff sitting on your desk. Come on, Tamir. You okay? Take your time and put them back in there, okay? Have a really good day. I love that. How you doing? How are you? How you doing? You okay? How you doing? How are you? Bro. Not back. This is I will show you. I will show you. I'm not sure. All right, your cell phone should already be in that bag when you come in. Calculator, yes. Cell phones, let's do it. Why are you picking up crayons, bitch? Number 3. Why are you picking up crayons? Somebody tell me to do that. Can you please put my cell phone? You gotta pass them on. Everyone was sitting in the gym. Why would you sit
Not anyway.
already have All right, let's work on the warm up. All right, let's work on our warm up. Gotta make sure that this focus is focused. Not distract this, okay? See what I said?
Yeah.
What did I say?
Help us focus.
And not what?
Distract.
Okay. So what are we supposed to be doing right now?
Warm up.
Warm up.
I'm not doing
I'll get you.
Can I get a paper?
Yes. Yeah. Yes, baby. All right, let's work on our warm up, please. Everybody should have their calculator. Cell phone should be in the caddy. Cell phone should be in the caddy.